Hello there! This presentation is going to discuss the methods and bias section related to our Psychology 121 class. Our first section focuses on identifying the process behind the results and identifying exactly what that means. Our snapshots that we're going to focus on is a little bit more about the scientific method as well as the 6 critical thinking questions used to minimize misconceptions. We're also going to take a look at the difference between algorithms and heuristics to solve our problems. So let's take a look at some of these questions. Considering the first one, is pro-choice abortion bad for society? Do you think that's something that we can actually answer with science? And as you're looking at this one, if you're thinking, nope, you are absolutely correct. This is an ethical issue that we would not be able to come up with a falsifiable or verifiable response. But let's take a look at the second one. Do people talk more after they have eaten than they do when they are hungry? Well, if we think about the actual terms in this one, we think about hungry, we think about more or less, this is absolutely something that we can test with science. What about the next one? Does jogging lead to a positive mental attitude? Well, again, we'd have to think about our objectives. So we're thinking about jogging. We might have to consider how much jogging. We might need to consider what exactly is a positive mental attitude. But is this an ethical issue, or is it something that science can answer? Well, if you're thinking that science can answer it, you are absolutely right. For number 4, are the incomes of doctors related to the grades they make in medical school? Now, as we look at this one, we might be going, well, you know what, we can't quite test this one in an experiment. Either it's there or it's not. But because it's something that either exists or doesn't exist, it is indeed falsifiable. And this is something that would be tested in a correlational study, which we'll talk about a little later. Then we have number 5. Which emotion is stronger, love or anger? Can this one be tested with science? Well, we would need to identify what emotion is. We would need to identify how to determine the strength, what exactly love is, what exactly anger is. So though it's possible to create something in this scenario, it's going to be very difficult. And we're going to say no to this one simply due to the abstract terms in the question. Let's consider number 6. Are breastfed babies more alert than bottle-fed babies? Well, we have a comparison, so that's a good sign for many scientific experiments. And we can certainly categorize the alertness and have the 2 separate categories. So that one's definitely something that science can answer. And let's consider this last one. Will people be more moral in the year 2020 than they are today? So what do you think? Can science answer this one? Well, if you focused in on the word moral in this one, it's taking us right back to the first question. It's going to be very difficult for us to identify this one, and so we're going to say no. Additionally, it's more of a prediction for what's going to happen in 2020, and so we can't verify or falsify it until 2020 is going to happen. Just keeping in mind that as we go through these different questions, though science can answer a tremendous number of questions, it's not appropriate for answering everything, particularly ethics, particularly morality. The APA, or the American Psychological Association, has specific rules for what can and cannot be tested relating to ethics, but we also want to consider things that have to do with preferences, issues, religion, or just overall concepts about our environment that can't necessarily be tested and can't be put into standard objectional terms, such as the question that had to do with love or anger. As just a quick review, we have our scientific method. So again, we want to make sure that we address the hypothesis, ask if it's falsifiable, whether or not it has operational definitions. The data that's then determined has to be objective and verifiable. We need to analyze those results and publish. As part of the scientific method, we do need to consider the best strategy for actually breaking down and solving any hypothesis. So we have to start with identifying the problem and selecting a good strategy. Now, there are a couple different kinds of strategies. First of all, you have algorithms. Now, algorithms are essentially procedures that are somewhat like formulas. These are procedures that are guaranteeing a correct outcome if they're applied correctly. So for an algorithm, if you were to put in some sort of piece of data, maybe a year for example, you would get out an estimated value, such as the population. Now with these different values in the algorithms, these are great for scenarios that have already been tried and tested and have concrete answers. However, in science, we oftentimes don't have these procedures already built out for us. And so that's where our second strategy of heuristics comes into play. Heuristics are shortcuts that don't guarantee a correct solution, but allow us to use our existing knowledge in order to break things down. So let's take a closer look at algorithms versus heuristics. So take a moment here and try to unscramble these words and consider if there's any algorithms or heuristics that underlie your solutions. Okay, so let's see how many that you got. Now, if you struggled with this, don't feel bad. This is definitely a hard exercise. But let's take a look and see if the algorithm for solving the words on the left impacted your words on the right. To get the words on the left, what we're looking at is we take the first three letters, and then we're using the first two. So this example turns into linen. We then can do the same thing with the next one. We get the first three, so SCE, and then we take those first two letters and we reverse them, and so that turns into scene. And we can continue going all the way down with that. So we get LEN, and then DS, so we get lens. Now if we apply that algorithm, so it's essentially something that if we plug in the process, we get the same answer every time. If we start doing that on the left, so we would get, for example, spears. Oh, actually just spear. And then for the next one, we would get STA, LK, stalk. We would get LEM, ON, or lemon. And so as we go through this scenario, we can say, okay, so we are indeed following these algorithms. But take a closer look at everything on the right now. Not only do we have those original answers, such as spear and talks and lemon, but we can also get other variations. So instead of spear, for example, we can get pears. When we use algorithms, one of the challenges is that we tend to not look outside the box, and that can make it more difficult for us to come up with our actual answers. So though the algorithms can be very useful for helping us find patterns and solve things, we also have to be aware of outside the box thinking. Now, in addition to those algorithms, we also have heuristics. Some common heuristics, these are shortcuts, allow us to work backwards. So let's say, for example, you were working on getting an A in my psychology class. Well, rather than just starting off the semester and going through it day by day, you would say, okay, well, what do I need to do to get an A? You would read through the addendum, you would read through the assignments, create a plan, and essentially work your way backwards. Additionally, you would look for analogies. So, for example, you may look for opportunities to find connections between ideas. So what had you done in previous classes that worked? What had you done in previous classes that didn't work? And apply those same concepts over and over. Another very helpful aspect of heuristics is to take bigger problems and break them down into smaller problems. So, for example, you might go in and say, rather than working on my research project all at one time, I'm going to break it up into parts. I'm going to make a plan for when my thesis is due. I'm going to make a plan for when my first draft is due. I'm going to make a plan for when my peer editing is going to be due, and when I can go ahead and rewrite it. So these heuristics can help us create a more manageable plan for all of the steps involved. Now, in addition to the heuristics, we also have to keep in mind that as we're dealing with psychological research and the scientific method, there are different ways that we can attack the scientific method. And we have to remember that each of these different types of research has their pros and cons. So let's take a closer look at each of these. Starting off with experiments. Experiments are situations where the researcher is controlling all of the conditions. We have our independent, dependent, and confounding variables. The independent variable is what is being controlled by the experimenter. So, for example, in an experiment where we're trying to heat up different liquids, the actual changing of the temperature would be the independent variable. It's changing, but it's being controlled by the experimenter. The dependent variable, on the other hand, is what we're measuring. So in the case of a science experiment where we're heating up liquids, the dependent variable might be where that liquid starts to boil or starts to actually evaporate. And for confounding variables, these are things that could skew the data results. And so we need to make sure that we avoid them as much as possible with experiments. The nice thing about experiments is since they do have controlled situations, we're able to remove those extra pieces. So, for example, if we're continuing with the experiment of testing how different temperatures are actually connecting to the boiling points of different liquids, a confounding variable might be how much liquid we have in a container, or the material that the containers are made of. We can make those consistent across our experiments so that way we can more closely test the independent and dependent variable relationships. When we're dealing with experiments, we also have different types of groups. So we have experimental groups, which these are the groups that are actually getting some sort of change done to them. And oftentimes we have a control group, which includes placebo groups. And to help us make sure that there's no differences between the groups, random assignment is frequently used to determine whether or not subjects are in the experimental or the control group. So just to give you an example with this is generally done when testing out a new drug. So we might have two groups, the experimental group and a control group, and the control group is going to be receiving a placebo. So for the experimental group, we give them the actual drug. And for the control group, we give them a placebo, which is essentially a sugar pill and not the actual drug. If at the end of the experiment these two groups respond similarly, then we can conclude that the drug itself did not create any major changes. On the other hand, if there is a major difference, then we would be able to say that the drug did have some sort of impact. So experiments are beneficial when you do have controlled variables, when you have very specific things that you're looking for, and that you will be able to get rid of as many confounding variables as possible. Another type of psychological research, though, are case studies. And in contrast to experiments, case studies are generally in situations where you don't have very many subjects. So this might be in some sort of psychological disorder, or this might be in a situation where we have victims and we're treating them for some sort of mental condition, or we're trying to see if they're able to get better based off of some sort of drug. So because we don't have situations where we have lots of people, that does limit the generalizability. However, it does give us very specific scenarios that we can test special circumstances. Another type of psychological research involves surveys. Surveys are best when we're looking for opinions, and oftentimes when we're looking for a wide range of data. Surveys, even when we're searching for qualitative data, such as how happy someone is, we can still turn that into quantitative data. So for example, we might have a question that says, how likely are you to vote for a particular candidate on a scale of 1 to 5? Well, that likelihood of voting is now something that we're able to quantitatively determine. A fourth type of psychological research are naturalistic observations. These are equivalent to people watching. So the naturalistic observations are done in situations where the experimenter is not directly involved. And if the researcher is not directly involved, the downside to this is that there could be many confounding variables. But the benefit of this type of option, this naturalistic observation, is that we're able to really see things as they're directly happening. We don't have to worry about people believing that they're in an experiment. We oftentimes get much more verifiable and true data when doing naturalistic observations. And lastly, we're dealing with correlational studies. So correlational studies, as opposed to experiments, are really focused on the relationships between variables. We have to be very careful of the difference between causal relationships and correlational relationships. Causal situations means that one thing is actually creating something else, whereas a correlational relationship is just that two things are either directly related, meaning they're both going up at the same time, or as one thing goes up, another thing goes down. So let's look at a few examples of these different relationships. With correlational studies, you'll frequently see the R value in the experiments. And the R value has to do with the relationship between two different variables. The R value is on a scale of -1 to +1. And so if we go through and we look at this relationship, we can see how exactly they are connected. Again, are they connected directly? Are they connected inversely? And the strength of the value is going to tell us how strong that relationship is going to be. So let's think about, for example, money and education. Well, as we look at our income and our education, we would likely predict that as the money goes up, the education is also going up, and vice versa. So in this example, those would be considered directly correlated. Now, on the other hand, if we're taking a look at, say, smoking and health, well, now as smoking's going up, the health is probably going down. And that's what's known as an inverse relationship. So just to give you a little bit more of a visual, you'll oftentimes see these decimal numbers. So if we have a positive correlation where income and education are both going up at, say, 0.7, well, we have this direct relationship. As one goes up, the other goes up, and similarly, as one goes down, the other goes down. A graph might look something like this. You'll notice that not all of the points are directly on the line, but they tend to be generally around it. That 0.7 that we have means that 70% of those points are related to that line. So that's a pretty strong correlation. On the other hand, we can have negative correlations. So if we think about the relationship between smoking and exercise, well, as one goes up, the other goes down, and vice versa. So now here, if we have a negative 0.7 correlation, we still have a 70% relationship between the two. But now, instead of going up, we're going down with our overall line. So you'll notice that not every point is going to be on the line, but they're pretty well connected. And then lastly, we can have no correlation. So if we take a look at our results here and say we're looking at the relationship between height and GPA, we would get a correlation of 0, meaning that these things don't have any relationship whatsoever. So now at this point, you've had the opportunity to think about the scientific method, to think about how we can use some different types of pros and cons for the given studies, and been able to recognize the relationships. We've also had the opportunity to look at the similarities and differences between algorithms and heuristics. As we continue to think of outside-the-box thinking, we want to be able to recognize mental sets and understand what functional fixedness is. So a mental set is the tendency to respond to new problems in a manner that's been used for a previous problem. So for example, if you're in college, if you previously did well taking notes in outline form in one class, you're likely going to try to do that outline form again in another class. The challenge with this is that our previous challenges don't always match up. And so you might find that a different note-taking strategy is what's actually beneficial. Regardless, that mental set provides us that structure like a heuristic would. Functional fixedness is the inability to perceive a new use for an object associated with a different purpose. So functional fixedness is really a specific type of mental set. Again, it keeps us within our particular way of thinking. We tend not to come up with new and creative ideas because we do have these concrete rules. And similarly to those concrete rules, we also create our own rules about ourselves with self-imposed limitations. So these are unnecessary restrictions, and they involve a level of not being able to think about new possibilities and scenarios. In order to test these concepts, let's try a small problem. Without lifting your pen from the page, try to connect all 9 of these dots with 4 lines or less. They have to be straight lines. And in doing this, again, with 4 lines or less, there are 2 solutions. Take a few moments now and see if you can try them. So if you're like most students, you probably struggled with this scenario. You may have come up with one of the solutions. You may have seen this before as well. But very few students will come up with 2 solutions to this problem. So let's see what these solutions actually look like. So here's the first one. If we're using all 4 straight lines, Notice how, in this example, we've gone outside of the box in two different sections. The instructions did not say anything about having to stay within the confines of the 9 dots. So one of the challenges is most people don't look to that outside realm. Additionally, these lines crossed each other, and that also was not a requirement to the overall problem. Now, if you're looking at this, you're likely going, oh, yeah, okay, I get it. But wasn't there another way to solve it? And yes, there's actually a way to solve this with just 3 lines as well. So let's take a look at that one. Let me back up just a moment there, pause that. There we go. So what you'll notice with this example is, again, we went outside the box, but we also didn't go through the middle of the dots. This is another self-imposed limitation that oftentimes we create for ourselves. Now, yes, these dots are a little bit bigger than the original scenario that I had shown you, but that just means that our lines would have had to extend a little bit farther out. So recognizing that our self-imposed limitations exist and being able to adjust it so that way we can avoid them is going to help us really become great problem solvers. So at this point, what I'd like you to do is take out your methods worksheet. It's available in the assignment section of your Blackboard account. Go through, work through the methods worksheet examples. Use the study group option that's available for you in your Blackboard course to talk about some of the answers to this, or go ahead and work through it on your own. You'll want to be able to define all of the terms and work through the different scenarios. Once you're done working through the methods worksheet, take a look at the marshmallow video that's available on Blackboard and try not to peek before completing the worksheet. You'll see how we can use the scientific method to test all sorts of great things.